Hello students, in this video we are going to study about the volume of the solid submerged. Volume of the solid submerged. You know the body is floating. I have taken a container and I have taken a liquid, let us say even water, whose density is rho. And I have taken a solid wood, let us say, whose density is sigma, and the total volume of the body is capital V, and the submerged part is small v. Now we are going to study about the law of flotation and find out how much volume is submerged in the liquid. We were discussing about tip of an iceberg in the sea, right? And this is the part which is above the sea. Okay, now we also can calculate how much is being submerged below the water. This is the discussion in this video. First, what we will do, we will study about what is the weight of the solid. Okay, you know weight of the solid is equal to weight of the liquid displaced. Then the body will float. The condition for flotation is the weight of the liquid displaced should be equal to the weight of the body. Okay, so I write weight of the solid or body is equal to weight of the liquid displaced. Okay, so this is the point here. Okay, weight of the liquid displaced. We know that according to Archimedes principle, we know that weight is written as V rho g, which is equal to V rho g. This is a standard formula. First we will write the standard formula. Now, weight of the solid body. What is the density of the solid? Sigma. So I replace this by sigma. Okay. Weight of the liquid displaced. Weight of the liquid displaced. How much here volume? How much volume will be displaced? Volume of liquid displaced will be equal to the volume of the shaded part, because only the shaded part is below the level of water. So shaded part has a volume small v. So this much only liquid will be displaced, the volume will be same. Okay, so instead of capital V, I can substitute small v. I hope you understand, dear students. Okay, so don't get confused. One is weight of the solid, that is V sigma g. There the total volume is there, that is the weight. Here weight of the liquid displaced. How much weight is displaced? Again V rho g, where rho is the density of the liquid, g is acceleration due to gravity. But how much volume will come out? The amount which is submerged, only that much volume of water will come out. Okay, so naturally it is a small v. Okay, we will do one thing here. G gets cancelled, right? We will take a formula V upon, that is volume submerged divided by the total volume is equal to sigma is as it is here divided by rho. What is this sigma upon rho? This is nothing but density of solid, which is going to be here, and floating, and the density of liquid. Okay, so we can easily use this formula to solve problems. See, V upon V is equal to sigma upon rho. This is the formula which we can use it to find out how much volume is submerged. Or we also can calculate so many things. Now in this video, I would like to do two numericals based on this concept. Okay, so let me first erase this, right? Remember, weight of the liquid displaced should be equal to the weight of the body then the flotation take place. Now, I am taking two numericals, right? I am using ICSE Concise Physics of 9th standard, Selena Publishers, right? And this is very common, okay? A block of iron floats on mercury. A block of iron floats on mercury, right? Mercury is a denser object, okay, which remains immersed. Find the fraction V dash, V immersed in the liquid, immersed in mercury. Now what are the data given? Density of iron. Density, what is iron? Iron is the solid which is going to be floating here. Okay, sigma is equal to 7.8 gram per cubic centimeter. And second, density of mercury, that is rho, the liquid in which the body is floating, rho is equal to 13.6 gram per cubic centimeter, right? So these are the two things are there. With this we have to find out what is V, we have to calculate which fraction, how much fraction is going to float. Very simple. V upon capital V is equal to sigma upon rho. Sigma is given to be 7.8 divided by rho is 13.6. That is equal to 78 upon 136. Okay, that is V upon V, capital V. That is V, small v is volume submerged and capital V is the total volume. So if you solve this, let me do it, 7, 8, okay, and there is 136, okay, it will not go, put a point here, bring a 0, 5 times, let us say, orange 30 cipher, midi 3, I 3 15, 16, 17, 18, 8, midi 1, 5, 6, okay, now this is 0, 0, 100, it will not go now, so 0 you put it, okay. This will go on 5 times, 6 times, let us say 7 times, okay, 67, 42, மீதி 4, 7, 21, 25, மீதி 2, 7, 9, right, 0.57, that is 0.57 is V upon V, or V is equal to 0.57 times the total volume. That is around 0.6 you can imagine, right? 0.6 is submerged and again 0.4 will be up. So the total volume will become 1. I hope you understand. This is a very simple problem. Now, I would like to do one more problem, right? From the same book. Let me take the problem clearly. Yeah. This problem. A block of wood floats on water with 2/5 of its volume above the surface. 2/5 of its volume above the surface, right? If 2/5 is above, how much will be below? So we will say below or submerged. How much is submerged? Okay, that is total is volume is V. In this 2/5 is submerged. So the volume which will be submerged will be, so 2/5 is above, so that is 1 minus 2/5 of V, that is equal to 3/5 V. That is the volume which is being submerged. As I read further, calculate the density of wood. Calculate density of the wood. Wood is the body which is floating, that is sigma. Sigma is equal to how much? When rho, density of water, is 1 gram per cubic centimeter. Okay, now it's very simple, we can do it now. Formula V upon V is equal to sigma upon rho, which is equal to sigma, we need to calculate. Okay, so we can write from here sigma is equal to V upon capital V of rho. Okay, so this is we can take this one, which implies okay. So V that is 3 by 5 V upon capital V is the total value, which is equal to 1 into sigma is 1 into this sigma, so rho is 1. V gets cancelled, right, is equal to, okay, sigma is equal to 3 by 5, that is equal to 3 by 5 is nothing but 0.6 gram per cubic centimeter. So this is the density of wood, which is 0.6 gram per cubic. So we know that in the case of flotation, you will find that sigma should be smaller than rho, or the density of the liquid should be more than the density of the solid, then the body will float. The condition for flotation is, this is the condition. So you see this is 1 and this is 0.6. So there are so many other problems in this, okay, and it should not be a problem once we can solve many of them, right. I would like to do one more problem, as I feel that I have time for solving one more problem with you, okay. Let me see this problem. Yeah, this is a problem on iceberg. If you do this, it will be better, I feel. Okay, so let me erase this part. Very simple, in NEET exam and all it comes, quickly you can substitute it and you can solve this problem. Okay, I will read the problem. An iceberg floats on fresh water with a part of it outside the water surface. Calculate the fraction of volume of the iceberg which is below. So V is equal to how much? Okay, below the water. Given density of ice, which is sigma, the solid 917 kilogram per meter cube. Okay, and the density of water is 1000 kg per meter cube. Keep these two things in mind. Okay, fresh water is this much, not salt water, this is fresh water. Okay, so which part is the total volume is V. V is equal to, we know that total volume is V. Okay, we are going to express in terms of the total volume. Okay, take this formula, we will directly take this. V upon total volume is equal to sigma 917 upon 1000, which is equal to 0.917. That is equal to 0.92. I am going to take it, simplify. So V is equal to capital V. 0.92 part is below the surface. You see here 1 minus 1.00 minus 0.92. Okay, 92 when you do, 0.08 is coming. Remember, only 0.08 is above. And the majority 0.92 is below. This is called tip of the iceberg. This is you have to understand. The densities are very close here. That is why in the sea we said Titanic ship is there. Titanic ship sank. Why did it sink? Because as the ship was going, though the ship was fantastic, the ship was highly well structured, well engineered, but due to a little bit of misunderstanding, or somebody say they slept, or captain didn't notice it. Okay, but when a ship is going with so many nautical miles, you cannot stop it suddenly. You cannot just stop it. Inertia will act. Even if you stop it, close it, then too the inertia will take it and go forward direction. And you such a large ship, you can't turn it easily, right? You know, it will just skid off. It will just tilt off. Okay, so naturally it will sink. So they went and hit against the tip of the iceberg. That is why we say a big problem is there. The tip of the iceberg is only 0.08 and submerged part is a very large quantity, 0.92. So that is why one should be. So whenever there is a big problem, we say this problem is only tip of the iceberg. That means so much is lying down and which has to be taken care of, and that is very important. And this way, using law of flotation, we will be able to find out what is the volume of the solid submerged in a liquid. Right? Thank you so much. We will continue in the next video more concepts. Thank you.